Hello everyone. Just a quick video to show you how to control a 8 relay board with the Moteino using a shift register. I got this idea from the low power lab from Felix Russo, and it has a very nice shield to attach a Moteino so that you can do exactly what I wanted. However, you still have to add the triacs or relays or whatever in order to control them. So this shield only has the outputs from the registers, in this case two 74HC595 shift registers that expand the output pins from the data clock and latch from the Moteino in order to get 8 plus 8 extra outputs to control the sprinkler valves. So I have here all the 8 relays that I want to control. I only have 6 valves, so I have 2 extra for whatever. These relays are controlled via optical isolators, and each optical isolator is driven by a small transistor that is controlled by the output of the shift register. And you have to be careful if you want to do this project by choosing the right type of board. Some of these boards are the relay will only turn on when the pins go low, and I wanted them to go on when the pins go high. So this board is the correct one. I can show you the nice board just like this one. I'm sure you can find this in a lower price, and here you have one exactly like mine. To find out how to connect the shift register to my relay board, I looked up in the internet and I found this article on Arduino.cc site, not the Arduino.org site. This article was written by Carolyn Moe and Tom Igo. So this article basically shows us how to connect the shift register to an Arduino board in order to control some LEDs. So here is an example, just like the one I used. It has one shift register and 8 LEDs and the Arduino. So in my case I'm using relays, and the shift register is the same. And instead of the Arduino, I'm using a Moteino, which is a Arduino clone with a radio. So if you check the data sheet, you can see that there are 8 output pins. Like it starts on Q0 on pin 15 and then goes from pin 1 to pin 7 on Q1 to up to 7. So it's 0 to 7, that's 8 output pins that you can connect to whatever you want. And the chip is also connected to the ground. There's a pin which is an overflow pin. When you register more than the limit of bits that the shift register allow, the extra bits will be dumped into this pin to another shift register that you may connect in cascade mode to this one. So if you keep on adding shift registers, you just keep on increasing on 8 bits of output every time you do that. And you connect it also to 5 volts. There are some extra pins that are explained right here. Some of them are connected to the ground, some are connected to 5 volts permanently, And in this case, pin 11 is the clock pin that you connect to the Moteino, to what will be the clock pin. And you also have the on pin 12 the latch pin. This one is the pin that must be enabled in order to present all the bits that are in the register to be dumped onto the output pins. And there is also the data pin, which is the pin that you use to send serial data into the shift register. You can see a very nice video about how the shift register works on this link. So in my setup I have the relay board. I have a Moteino that is considered a receiver. I have another Moteino that is considered a sender. So all the commands are sent via the serial monitor of this Moteino to this one, which will parse the commands that will send the data through the data wire to the shift register, that will dump the bits out through the output pins into the relay board. So each Moteino is loaded with a different sketch. One is the sketch that you can find in the RFM69 library examples folder, which is the IO Shield UNO. I changed the name, but it's the IO Shield.UNO. And the other one has a different sketch that I created in order to parse the commands out to the serial monitor. So in the IO Shield.UNO you have a header with all the instructions on how to use it. These are the commands that you must send to the Moteino in order to control the relay board. And next you have all the usual definitions for the radio. So set up the correct gateway ID, the node ID, and the network ID. So these must be the same on both. You can see that they both have the same network ID. This is the sender, not Moteino, the one that is sending commands to this board. So this is that must be the same as on this side, and this is the node number of the receiver. Moteino must be the same as this one is a destination node ID. You can of course choose these numbers the way you want, as long as they match on both sides. Then choose the correct frequencies, the same encryption key for both radios, and if it is a high-powered RFM69, just uncomment this line on both sides, of course. And these next instructions prepare the Moteino to use the latch pin, the clock pin, and the data pin to control the register, the shift register. And here you define how many shift registers you have. So in my case I only have one. I changed it from 2, which was on the original sketch, to 1. This is some more trivial stuff. This will allow you to see what's going on the serial monitor. Start up the radio, the flash chip. Then initiate the serial port. This one is on port 14, the other one is on port 25. Of course, you will have a different ports on yours. So the radio is initialized here, and then we'll have some variables set up, the main loop, and here's where the radio is waiting for some instructions. The instructions will come out from the radio data variable, and this is only to allow this Moteino to be wirelessly programmed. You can check my other video regarding the wireless programming of the Moteinos. Then the instructions that were inside the radio data variable are parsed, and the commands are looked for. So here's the off command. It sends it to the zones off function directly. If it is a all command, it goes directly to the zone all on function. Otherwise, it must be a on command, and then it will try to figure out which sector or relay we are trying to turn on. And there is also a possibility that is programming, that I am programming some relay to be on for some amount of time like this. So for instance, this one is program relay 1 to be on by 5 seconds, then it will shut off and turn on relay 2 for 5 seconds, 3 for 10, and so on. And then there's all these the commands that allow this to happen. I'm not going into a lot of detail on how they work, so we can find all these the functions that I talked about is the zone on function, the zone off function, and so on. On this side, I have also the setup for the radios and all those normal definitions. Turn on the possibility to see what's going on the serial monitor. Then start the radio, the flash, shift, turn on the serial port, the serial monitor, so that I can see what's going on. Initiate the radio instance, and you have to set this up, of course, it's the same as the other one. Then the main loop. So I have here this section, which is if radio receive done, which will try to figure out what the other Moteino is sending back as a feedback of its actions. And here is just the part where it allows this Moteino to be wirelessly programmed. And on this loop, if loop, I'm going to check what's coming out of the serial monitor command line. So as soon as I write some command and I press enter, it will start to assign these data into various variables, and up to a point where then it is sent by the radio to the destination node ID and waits for an acknowledge. And as soon as the acknowledge is received, it will be displayed on the serial monitor, and the LED is onboard LED is blinked from this function. It's now I'm going to load both sketches on both Moteino. So this one is being uploaded, and this one is being uploaded. Okay. So both, well, this one is already loaded, and this one is finishing up, and it's finished. Okay, so now I'm going to open the serial monitor, and this is from the receiver. So This is the monitor of the Moteino that has the relay board connected to. So it's gives you here some just some text to show me what's going on. It's the I/O shield. It's working at 433 megahertz. It says it's started, and the SPI flash is okay, and received the okay from the acknowledge from the other board, and tells me how much RAM I have available. So on the other side, this is the transmitter. So it says me that it's transmitting at 433 megahertz, which must be the same as this side, of course. So now I'm going to send the all command to, let's pull this down so that you can see the boards. All command. So it gives me feedback of the command I gave, and sends the instructions via radio to this one. This one tells me that it received these instructions from radio ID number 9, which is okay. The command is this one, and the level of the signal radio signal that is transmitted, and then sends an acknowledge back. This one tells me that the acknowledge is received, and here's where it said the acknowledge was sent, and again how much free memory I have now. So you can see that all the LEDs came on, so all the relays are now on. Now I'm going to send the off instructions. Okay, so same thing happened. Instruction is repeated here, and it was sent via radio. This one received this instruction and sent an acknowledge, and an acknowledge was received, and also tells me that what instruction was received from the other radio. It says zones off. So now I'm going to turn relay number 1 on. It's writing on and number 1. So only this relay is on, all the others are off. So now I'm going to turn relay number 2 on, which will turn relay number 1 off and turn on relay number 2. There it goes. So this one is on, this one is off. And I could do this to all the others. So now I'm going to set up a program. Imagine that I want to program my sprinklers to start this one for 10 seconds, and then this one 10 seconds, then this one, and so on. So I issue a programming command like this. Now I tell him which one is the first one, sector number 1, how much time, let's say 3 seconds. Then number 2, 3 seconds, 3, 4, and 5. So the instructions were sent. This one was already finished. This one is starting now, now this one, and at the end, that one. And, oh, sorry, there's the last one right there. And now at the end, they shut off. That's it. So now all I have to do is to connect this to my sprinkler system and connect it to the Moteino that I already have next to it to control my sprinkler system from my home automation. I hope you enjoyed the video. Thank you.